Hello and welcome back. This is the third video of Unit 1, an introduction to machine learning. This video is going to cover artificial intelligence versus machine learning. What are the differences? Where are there similarities? Hopefully those questions will be able to be answered by the end of this video. So let's get started. What is the difference? How is artificial intelligence even defined? And we can start by that here. This is the definition that Google provides. Artificial intelligence is simply the theory and development of computer systems that are able to perform tasks that normally require human intelligence. So these tasks include things such as visual perception, speech recognition, decision making, translation. All of these tasks are normally performed by humans, but notice that the definition does not require a means of accomplishing those tasks. So regardless of how we do visual perception, or regardless of how we do speech recognition, we're still going to be using artificial intelligence as long as it's done on a computer system. So let's contrast that a little bit with machine learning. And machine learning can be really defined as a subset of artificial intelligence because it's often used to accomplish tasks like speech recognition. This is a computer program that can be used to do AI tasks. In 1959, Arthur Samuel was really credited with the idea for machine learning. He decided that we could teach computers how to learn instead of trying to give them a large rule set or teach them every single little thing that they would need to know about the world. So this is more similar to how you and I think, and really began the route towards machine learning. However, it wasn't necessarily possible until we developed the internet and we started collecting all of this data. So the data is really the essential part of machine learning because we have to learn from past experience. So until we had good data sets developed, we couldn't do much machine learning. However, now that we have that, we're able to accomplish some of the tasks that were noted in our AI definition in the first slide. However, what machine learning is not is probably a better way to understand the differences between artificial intelligence and machine learning. First, machine learning is not logic. It is not rule satisfaction. So for example, if we had a simple logic scenario like if A meets B and B knows C, does A know C? This is a question that machine learning would not be able to answer. Again, remember, machine learning is based in statistics. It's not necessarily based in logic. So when it comes to logic and rule satisfaction, we have to rule machine learning out. Machine learning is not artificial intelligence in the sense that it has an understanding of the world. And we'll give you some more examples of why machine learning doesn't understand in a second. But when we picture artificial intelligence, we're typically thinking about something like Sunny from iRobot. If you've seen iRobot, Sunny is a robot who starts to display emotions like anger or love. Artificial intelligence right now isn't able to do that because machine learning doesn't display understandings or emotions in this way. Finally, machine learning is not biology and neuroscience. We do have neural networks which are inspired by biology. However, they have no requirement to function in the same way that our brain does. For example, we built fighter jets and they work great. However, fighter jets don't flap their wings like a bird does. Sometimes the best methods are not always the ones that are biologically inspired or similar to our own minds. So we have plenty of machine learning networks that aren't similar to what you might find in the brains of you or I. However, some of the networks are, and that is neural networks and deep learning specifically. Those will be covered more thoroughly in Unit 4 when we talk about neural networks. Convolutional neural networks are a really cool aspect of machine learning that are starting to be used for a lot of tasks. So we'll talk about that later, but it's important to know that machine learning is not a study of neuroscience or a study of biology. So here's an example of why a machine learning algorithm does not understand. And that example is adversarial imagery. So this would be a deep neural network, and it's being used for image classification tasks. So on the left here, we have a panda, which is classifying with fairly good confidence. However, if we perturb the pixel intensities by a very slight amount, in this case 0.007%, of what seems like a random direction, we are going to trick the machine learning algorithm to classifying this image as something entirely different. In this case, a given it thinks it's a monkey on the right with 99.3% confidence. If you look at the image on the left and the image on the right, you and I could not tell the difference between these two images. However, the machine learning network is entirely fooled. And that's because we've changed the image ever so slightly in the most significant direction possible. You notice the gradient below the middle image and the right image. We're moving in the direction of the most damaging direction, and we're very easily able to trick the machine learning network. You and I can understand that these images are the same. These are both pandas. However, because of the way machine learning networks work, it doesn't understand that there's not a significant difference between these images. And there's plenty of examples of adversarial imagery and other adversarial examples out there on the internet. I would encourage you to research them further if you wanted to understand more about what a machine learning network can understand. Okay, so let's move on. We also talked about rule satisfaction. A rule-based AI system has been around for a while. Here was an example, Eliza, and you can see this interaction where the rule-based AI is trying to fill the role of a psychotherapist. However, the user quickly becomes frustrated simply because the answers and the questions that this AI is asking don't necessarily make sense. You may have noticed this when you're interacting with a chatbot online or something of that nature. Rule-based AI systems don't always work. And this is not machine learning. This is an example of an artificial intelligence that doesn't use machine learning. Granted, this was in 1970. We have much better systems out there today. However, this is just a good example to show that artificial intelligence doesn't always have to be machine learning. We can accomplish tasks like speech recognition without using machine learning in a lot of different scenarios. Visual perception doesn't always have to be machine learning based. We can do static image processing and actually solve many computer vision tasks more effectively than using deep learning methods, simply using thresholding techniques or contour detection, something like that. So artificial intelligence doesn't have to be machine learning. However, in many scenarios, it does use it. Machine learning can be considered the new cutting edge of artificial intelligence research. So visual perception tasks, we are starting to develop deep learning networks that are really good at visual perception. Natural language processing would be another example of a scenario where we're using machine learning algorithms to form an artificial intelligence role, and we're doing it quite well. So with the advent of deep learning, we've really increased the complexity and the advent of the neural network. These two things have improved artificial intelligence research significantly. So while AI doesn't have to be machine learning, it can use machine learning in a lot of scenarios to accomplish the task that it is trying to do. So that's just a quick summary on artificial intelligence and machine learning. I mentioned that this would be a short video. If you'd like to learn more about the differences, we can go into that in more detail in the future units, such as Unit 4, when we're talking about deep learning and neural networks specifically. When we think about machine learning and artificial intelligence, it's often that neural network that people are imagining. In our next video, we're going to talk about the core math competencies for machine learning and artificial intelligence research.